Hello everyone. Today we are going to start one more new chapter from our 10th class textbook, that is carbon and its compounds. Carbon and its compounds. So that means in this chapter we are going to discuss about carbon and its compounds. Actually, we have discussed in our last classes in periodic classification that until now more than 115 elements are discovered. Until now more than 115 elements are discovered, but we are discussing specially about the carbon. This carbon atom is also one of the elements from these 115 elements. But why we are discussing specially about the carbon atom? What is the speciality? Okay, and how it can able to form compounds, that we are going to discuss in this chapter. What is our chapter? Carbon and its compounds. Right? Why we are discussing specially, then what food we are taking, in that food carbon will present. The clothes which we are wearing, in that also carbon is present. And vehicles, we are using the fuels in the vehicles, the fuel also contains carbon. So whatever it may be, what are the things we are using in our day-to-day life, out of that all items, minimum 90% of things contains this carbon. The 90% of things are belonging to carbon compounds. So that's why we are going to discuss specially about the carbon. That's why we are going to discuss specially about the carbon. Okay, right. Then carbon symbol is C. Carbon symbol is C. It is belonging to 14th group. Okay, it is belonging to 14th group and or 4A. Okay, it is belonging to 14th group or 4th A group. Okay, and carbon's atomic number is 6. Carbon atomic number is 6. So that means it contains 6 protons, 6 neutrons and 6 electrons. 6 protons, 6 neutrons and 6 electrons. That means its structure. So nucleus contains protons and neutrons. Nucleus of it contains protons and neutrons. So 6 protons with the 6 neutrons. Okay, and then remaining electrons will fill in it. Here 2 electrons are in the K shell and remaining 2 electrons are in L shell. So its electronic configuration we will written as 1s2, 2s2, 2p2. 1s2, 2s2, 2p2. Right? So 2 electrons in K shell and remaining 4 electrons are present in L shell. So what is the valency? What is the valency of this carbon atom? Okay, that is tetravalent. Tetra means 4. Its valence is 4. Okay, right? Its valence is 4. It present in a 14th group. Here we know is that every atom is trying to get octet electronic configuration, stable electronic configuration, magic electronic configuration, right? Always every atom is trying to get a magic figure in its outermost shell. Octet electronic configuration, we have discussed that. What is octet electronic configuration? Octet rule means achieving of 8 electrons in its outermost shell is called as octet rule. So here, how many electrons are present in carbon atom? It contains only 4 electrons. It contains 4 electrons in its outermost shell. So like other elements, like other atoms, then carbon also always trying to get a stable electronic configuration. Always it's trying to get a octet electronic configuration. How it is possible, sir? How it get octet electronic configuration, sir? To achieve the octet configuration, the atoms are participate in chemical bondings. We discussed now, the atoms are participate in chemical bonding, right? Why atoms are combined to get octet electronic configuration, right? Here in the chemical bonding, we have discussed 2 types of chemical bondings. In that first one, ionic compound. Ionic compound. Sir, what is ionic compound? Ionic compound means the transfer of electrons. What? Transfer of electrons. Okay. Then here we will discuss whether the carbon atom can participate in the ionic bond. By ionic bonding, it can get a ionic bond, not compound, ionic bond. Here I have written ionic bond. So ionic bond means transfer of electrons. So whether the carbon atom can participate in ionic bondings, through ionic bonding it can get a octet electronic configuration. Let me investigate it. We will check it. Let me recall it. Then see here. So here it's a required 4 electrons. How many electrons? Already in its outermost shell it has 4 electrons. No, then still extra 4 electrons is required to get octet electronic configuration, right? Then if think one, any atom or any element is ready to give the 4 electrons to the carbon atom. Any atom or any element is ready to give the 4 electrons to the carbon atom? No. So no element is not ready to lose that much amount of electrons. Okay, whether then it get a 4 electrons. For example, let you think the 4 electrons is gained or given, some X element is given 4 electrons to the carbon atom. Then how many electrons? Then total electrons becomes, the protons are 6, and when after getting the extra electrons, already it has 6 electrons. If any atom is given still 4 electrons, then total number of electrons becomes 10. Total electrons becomes 10. And here you know that electronegativity of the carbon atom is 2.5, very less. So it is impossible to gain the 4 electrons. Okay, even if it is gained the 4 electrons, it has only 4 protons. The 4 protons are unable to control the 10 electrons in its outermost shell. Got it? The 4 electrons, then 6 protons are unable to control the 10 electrons. So if it is gain these 4 electrons also, the atom becomes unstable. The carbon atom becomes unstable. Actually, first of all, it has no capability to hold the 4 electrons, hold the 10 electrons. 10 means already it has 6, no. Again it gained 4 electrons extra, no. Right. The carbon electron is unable to hold the 10 electrons. It has no much energy to store, to control the 10 electrons with these 6 protons. So from this explanation we came to know that the gaining is impossible. Gaining is not possible. Okay, then that means it should not get a octet electronic configuration by gaining. Okay, for example, here it has one more chance. Okay, ionic bond means the atoms or elements are trying to get octet configuration by losing of electrons or otherwise by gaining of electrons. Right? From here we came to know that gaining is impossible. Gaining of electrons to get octet configuration by the carbon atom is not possible. Then here by losing, okay, by losing also it can able to get stable electronic configuration like helium. Helium's atomic number is 2. In outermost shell it has only 2 electrons. Only the helium atom is inert gas, 0 group element. It contains only 2 electrons, right? To get helium's electronic configuration, by the carbon, it should lose 4 electrons. How many? 4 electrons, right? If it loses the 4 electrons, it has 6 protons. If it loses the final calculation, then 4 protons will present in it in its nucleus and 2 electrons in shells. Then that means the force of attraction is greater from the nucleus on its shell. Then finally it becomes unstable. That means the gaining also, by losing also, it is not possible. Okay, so the carbon atom is unable to get octet electronic configuration by losing, by gaining also. That means the ionic bond is not possible with a carbon atom. Okay, right. So finally that means it should not achieve 4 plus or otherwise 4 minus. Okay, got it? Right. Then finally, so ionic bond is not possible with this, so we go for covalent bond, right? Covalent bond. So how the bond formation can take place in the carbon, right? So finally from this explanation we came to know that a covalent bond is possible with this carbon atom. Okay, right. How many covalent bonds it can able to form? How many covalent bonds it can able to form, sir? How many means? 4. Its valence is tetravalence, no. That means it can able to form 4 covalent bonds also. It can able to form 4 covalent bonds. Right. How it is formed, sir? Here, either it forms carbon atom, okay, it forms 4 covalent bonds with 4 similar atoms like this, CH4, or otherwise like this. Then it can able to form 4 identical atoms. It can able to form 4 covalent bonds with 4 identical atoms, CCl4, carbon tetrachloride, or otherwise it can able to form 4 single covalent. These all are single bond or not? It formed 4 covalent bonds, then 4 covalent bonds also single bonds only, right? Then this carbon atom is formed one single bond with this hydrogen atom, with this hydrogen atom one covalent bond, and with this hydrogen the carbon is formed one covalent bond, and with this hydrogen atom also it formed one covalent bond. Got it? So here with this chlorine one covalent bond, with this chlorine one covalent bond, with this one chlorine one covalent bond, with this chlorine atom also the carbon is formed one covalent bond. Sir, it can able to form 4 single covalent bonds with only identical atoms? No, it can able to form the 4 covalent single covalent bonds with different atoms also. See, hydrogen, bromine, chlorine, right? So this carbon atom can form 4 covalent bonds. The one covalent bond with this hydrogen atom, and one more covalent bond with chlorine atom, and one more covalent bond with bromine atom, and one covalent bond with the hydrogen atom. Like this, it has formed 4 covalent bonds with similar atoms, or otherwise with dissimilar atoms also. Okay. Right. Sir, it can able to form only single bonds, single covalent bonds. No, we will see here. Right. It can able to form double bonds also. Right, like this, carbon atom and carbon atom. This carbon atom can form 4 bonds. One carbon atom can able to form 4 covalent bonds, Nana. How many? 4 covalent bonds. Right? Why? Because it is valence is 4. Tetravalence. So that means, see here. Here this carbon atom forms one single bond with the hydrogen atom and another single bond with this hydrogen atom, right? Here this carbon can form one covalent bond and this also one. So here we have only 4 hydrogen atoms. The 4 hydrogen atoms are shared equally by the 2 carbon atoms, right? Out of 4 carbon atoms, 2 hydrogen atoms are shared by this carbon atom, for remaining 2 is bonded with this carbon atom. Then here still it is unbalanced. Okay, it can able to form 4 bonds, no, right? So 2 bonds are completed, then remaining bond can take place between these 2 carbon atoms only, between these 2 carbon atoms only, right? Got it? So here 2 lines, that means double bond. Right? See here, how many bonds it formed by this first carbon atom? Right, 1, 2, 3, 4, satisfied. That means this carbon atom is formed 2 single bonds with 2 different hydrogen atoms and 1 double bond with 1 carbon atom. Likewise, here this carbon also. Okay, right, I will give you one more example. Right? So carbon and carbon. Okay, right. Here this carbon atom is formed 1 double bond with oxygen. Okay, 2 bonds are completed and 1 more bond with the hydrogen atom. Then it can able to form 1 more bond, that is with this carbon atom. This carbon atom is formed 4 bonds. See, 1 single bond with this carbon atom and next single bond with this hydrogen atom, double bond with the oxygen atom, right? Then here this carbon atom can form H. See here, then this is also formed. Then 4 covalent bonds are not. 1 single bond with the hydrogen atom, another single bond with this hydrogen atom, another single bond with this hydrogen atom, and one bond between carbon to carbon. Okay, right. And next, sir, here it can able to form only single bond and only double bond. No, here it can able to form triple bond also. Then now we are going to write. Then see, here it has only two hydrogen atoms, right? Two hydrogen atoms are shared equally with the two carbons, right? This carbon can able to form 4 bonds. With this, one bond is completed. Still how many bonds? 3 bonds. This carbon also, one single bond is completed. Okay, remaining how many? 3 bonds. So triple bond can be takes place. Got it? Triple bond between 2 carbon atoms and one single bond with these hydrogen atoms. Right? This is the way it can able to form. Sir, only one single bond, double bond, triple bond, single bond can take place. No, it can able to get chance to get double bonds, both the double bonds also. Right? Carbon atom, carbon atom, carbon atom. See here. Here, this carbon atom is formed one single bond with this hydrogen, one single bond with this hydrogen, one single bond with this hydrogen, one single bond with this hydrogen. So this carbon atom can able to form 4 bonds. So 2 bonds are completed with 2 different hydrogen atoms. Here also 2 bonds is completed with 2 different hydrogen atoms. Then here it can able to form still 2 bonds, and this atom also can able to form 2 bonds. This atom 4 bonds, right? So then double bond between these 2 carbon atoms and one more double bond between these 2 carbon atoms. Got it? Here double bond takes place between these 2 carbon atoms. Right? Now finally this carbon atom is formed 4 bonds or not? 1, 2, 3, 4. Satisfied. This carbon atom is also formed 4 bonds. The one double bond, second double bond, then 2 double bonds. That means 4 bonds. And this carbon atom, one double bond, 2 single bonds, then 4. So finally we came to know that then it is forms, the carbon atom can able to form the single bonds with similar atoms or dissimilar atoms also, and carbon atom can able to form one double bond and remaining single bonds, and the carbon atom can able to form triple bonds also, and the carbon atom can able to form double bond also. Right? Okay, got it? Then here carbon atoms, atomic number 6. Here we will write electronic configuration as 1s2, 2s2, 2p2. Right? So here arrangement of electrons. Is this way. So here in its electronic configuration, it shows that 2 paired electrons, 2 unpaired electrons. How many unpaired electrons? Only 2 unpaired electrons. Right? So here it has only 2 unpaired electrons, no sir. Then how it forms 4 bonds? Here it has only 2 only 2 unpaired electrons, no. Then that means it should form only 2 bonds. But how it can able to form 4 bonds? 4 bonds means here this electronic configuration at a ground state. Okay, when it is in ground state. But when carbon atom in excited state, its electronic configuration is changed. Okay, right. Then here the electron promotion can take places when it is in excited state. The electron from 2s to orbital, then here this is as it is, then we will come here, then here it has 2s2 now, right, and here it has 2 electrons, okay, right. When it is in excited state, when it is in excited state, the electron can transferred from its 2s orbital to 2pz, 2s orbital to 2pz. Here you can see 2px, 2py, 2px, 2py and 2pz. Here when the atom is in excited state, the electron can jump from 2s orbital to 2pz orbital. Then finally its electronic configuration, then its arrangement of electrons may becomes like this, okay, 2s1, 2px, 2py, 2pz, right. This is the way the arrangement can be takes places, okay. When the atom is in excited state, the electron from the 2s orbital is jumps from 2s to 2px. Excited state means what? When the atom is gained the extra energy. When the atom is gained the extra energy, then the electrons can jumps. Okay, sir, you said when atom can get the extra energy, it gets into excited state. Okay, right. Sir, from where it gets the energy? From where it absorbs that extra energy? That energy can be takes places from the bond energies. When the carbon atom is ready to bond with another atom, right, then when the carbon atom is ready to bond with another atom, then from this bond energy is absorbed by the carbon atom, okay, bond energy is absorbed by the carbon atom and it promotes the electron from 2s orbital to 2pz orbital, 2s orbital to 2pz orbital. Actually, the carbon atom is always in ground state only, right? Always the carbon atom is in ground state. When it is ready to form the bond formations, then only it can absorb the energy and then only it get excited state. Okay, right. Then here and sir, electron is promoted and 4 unpaired electrons are there. So that's why it can form 4 bonds. How many bonds the carbon can form, sir? 2 bonds or 4 bonds? 4 bonds, right. Here, while bond formation takes place, they loses the energy. The atoms, the compound can loses the energy to get the stability. Which atom are having the more energy, trying to lose its energy to get the stability. Okay. How it can able to lose? While the chemical bonding, it can loses the energy, right. So that's why in which case it can able to lose more energy, by forming the 2 bonds or 4 bonds? By the 4 bonds. Number of bonds is increases, the more energy is releases and it becomes more stable. Okay, right. Then hereby this is the way the electron transformation can be takes place. Right here, just before in one example we discussed that CH4. So one carbon atom can forms 4 covalent bonds, right? Okay, 4 covalent bond means here which are the orbitals are participating in that? S orbital, 1 s orbital, 1 px orbital, 1 py orbital, 1 pz orbital. So 4 different orbitals are participating. The 4 orbitals are different in shape. The 4 orbitals are different in energy levels also. Right? In such cases, the bond angle should be different. The bond angle also should be different. But then Westport theory is proves that we have discussed in chemical bondings, then the bond angle in CH4 compound in molecule is 109 degrees. Okay, 109 degrees 28 minutes. But bond angle is same. But with here the different orbitals, s orbital, p orbital, y, px orbital, py orbital, pz orbitals. That means their energy is also different. The orbital energy is various. The bond angle also should various. But here experimentally we found, our scientists have found that the bond angle is exactly 109 degrees 28 minutes. Sir, how it is possible, sir? To know that, we have to discuss one more concept with the simple valence bond theory. By the covalent bond theory, it is not successfully explained. So we have to discuss one more theory, that is called hybridization. That is called hybridization. Okay, in our next class we are going to discuss hybridization. Thank you.